status check to proceed with terminal count, Atlas Systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2. Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2. LH2. Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFOTS.
Go.
Flight control.
Go.
DC cube.
Go.
COM.
Go.
Timer.
Go.
Umbilicals.
Go.
DCS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
CMD, you have permission to launch.
Proceeding with account.
3, 2, 1, mark.
With that, we see the fires lit, the engines start to roar, and lift off. Scott Tingle, Anton Shkaplerov, and Norshi Kinai on their way to the International Space Station.
7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity. Seeking clues, planetary puzzle on lifelong Mars. Sun suppression water system activated. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of Space Shuttle Atlantis. Mission to build, resupply, and to do research on the International Space Station.
Yes! We're live again. Just an hour after I finished. Or, not finished, but started. Continued building this one. The Atlas 5. As you can see on screen, they are. There is no. Yes, there is now. Okay, so you can see it. You can hear it. There we go. We have a launch host. So. Yeah. Whoa. ULA updated their whole viewing graphics stuff. So this is the most powerful version of the Atlas 5 they're using. They're using the 551, which means 5-meter fairing, 5 solid rocket boosters, and 1 engine on the center second stage. So right now they're in at T-4 minutes and holding. In I believe in 10 minutes or so they're gonna have a poll, and that's called the go no go, and all stations will be polled and they will decide if they're go or no go for launch. And if they're go, they're gonna continue the hold until they are at T-4 minutes till the I believe the opening of the launch window. They launched. They start the countdown again, and then it goes further. And this is going under, so they're launching actually 2 satellites. One is Eagle, which is not really a satellite, but it's a ring with experiments and 1 deployable satellite, I believe. And there is a satellite on top. I don't really know what they do. I haven't really researched it, but just woke up from my last hour and I was asleep well. I hope you slept well. But this is probably gonna be a really short one. They're gonna cut off the stream just after payload fairing deployment, I think. I'm not sure, I couldn't find anything on it, but
Well, to begin, the primary mission objective for the Eagle platform is to demonstrate a maneuverable ESPA-based space vehicle design which can accommodate 6 or more hosted or deployable payloads in geosynchronous orbit. Furthermore, the ESPA-based platform concept can be cost-effectively replicated for multiple payload missions to any orbital region.
Wow. What can you tell me about how Eagle got started?
Well, the Air Force Research Laboratory, or AFRL, Space Vehicles Directorate, has continuously conducted on-orbit experimentation for over...
So as you can see, I can demonstrate. All configurations of boosters, doesn't matter if it's 1 or 5, are not symmetrical. I can show if it sticks. So if I have 3, they will be configured like this. Yeah, well, cool. I love the new, yeah, this is the first time they're using it, but as you can see, if I have, it's a bit wonky, but if I have 3, they're not equally spaced, but definitely better graphics than before. Yes, definitely. definitely have better graphics.
Well, the AFRL Space Vehicles Director's mission is to develop and transition innovative low-payoff space
Right.
technologies supporting the warfighter, while leveraging commercial, civil, and other government space capabilities to ensure America's advantage.
What are some of the advancements that Eagle has compared to some of the prior experiments?
Well, prior AFRL Space Vehicle Director programs advanced safe spacecraft operations, as well as space situational awareness technologies and capabilities in various orbital regimes. The primary mission objective for the Eagle platform is to demonstrate a maneuverable ESPA-based space vehicle design which can accommodate up to 6 hosted or deployable payloads in geostationary Earth orbit and can be cost-effectively replicated for multiple payload missions to a geo, low Earth orbit, or geostationary transfer orbit.
Thank you so much for taking some time to talk to me about Eagle today, Melanie.
No problem. Glad to be here.
The armor and the payload variant of this evening's rocket consists of an Atlas V 551 rocket launching from Cape Canaveral Air Force Station. The dial is turned to 11 to capture the spirit of the AFSPC-11 government launch team and its mission, which is to maximize efforts to meet Department of Defense requirements to support our senior leaders and combatant commanders with war-winning space capabilities.
As you can see on the tower behind the rocket, the crew access arm for the Starliner is already installed. Ooh. They're gonna pull. They should be pulling in about, yeah. Round about now, they're
Go, Flight Control. Roger. All steps are complete prior to status check. LC is switched to the ready position.
there we go. Let's listen to the poll. So yeah, what you see coming out of the rocket is just the liquid oxygen that was vaporized.
As we continue to prepare for liftoff. In a few moments, Launch Conductor Scott Barney will pull the launch team for the final go to pick up the countdown. 28 engineers and managers will be pulled for system status and readiness to proceed with the
Ooh, I
launch.
like it. I
This is
like
the
it a
final
lot.
status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Launch Conductor Scott Barney performs the final polling of the team.
There we go. Polling.
Status check to proceed with terminal count. Respond go, no go. Atlas Systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2.
Go.
Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality. Go.
Yes.
Op safety manager.
Everything is go.
Relay
Hey.
safety officer.
Go.
Vehicle system engineer.
DSC is go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director. Launch vehicle is ready to launch. Mission director.
The CMD, you have permission to launch.
Yeah,
Proceeding
everything
with
is
the
go.
ALC, verify T0 is set for 2313 Zulu.
Verified.
Where's Simon? Maybe he fell asleep.
Polling is complete and the launch team has given the go for launch. From T-minus 4 minutes until launch, you will be listening to Launch Conductor Scott Barney and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas LO2 topping has
Yeah,
been secured,
it hypes
followed
me up
about a minute
too.
later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute and 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute and 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and AFSPC-11 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Patrick Moore providing launch vehicle ascent data.
So, yeah. Good launch. So there's,
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
so the pole.
Time will be T-minus 4 minutes and counting.
Mark.
3, 2, 1, mark.
The towers you see around the pad are
3
lightning
minutes 55.
towers.
Ground pyros enabled.
The countdown
doesn't
clock
look
has
white.
resumed and we are go for launch at
From one
7:13
ship.
p.m. Eastern.
What doesn't look white? The I guess he fell asleep. He's missing this. Oh, the booster. Yeah, but it is. There's ice on the outside. That's why it's white.
Atlas tanks to flight pressure.
2 minutes 50 seconds.
FDS internal.
Ooh, it's becoming hot. It's going hot, hot, hot. 2 minutes. Coming up on 2 minutes. Oh, my face is in
2
front of it.
minutes 10
Let me
seconds.
fix this.
Eagle on internal power.
Roger.
$159,
Vehicle internal.
$155,
Launch sequencer start.
$150,
Carrying Centaur LH2.
Carrying Centaur LO2.
Ooh, nice onboard camera,
140.
yes. So you can see all the ice falling
Launch
off.
enabled.
137,
FDS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
Yes, we're go for launch.
120,
OCU's armed.
SCS count started.
115,
Reduce ECS for launch.
Roger.
110,
Vent valves locked.
T-minus 1 minute.
T-minus 1 minute.
Report range status.
Range green.
For 45 seconds.
T-minus 40 seconds.
Stable at step 3.
Thirty seconds.
28 seconds.
ECS reduced for launch.
Roger.
25,
Status check.
Go Atlas.
Go Centaur.
Go AFSPC-11.
2 minutes. Ooh, pretty picture.
T-minus
T-minus
10,
10,
9,
9, 8, 7, 6, 5, 4, 3,
We have ignition.
2,
2,
1.
1.
Liftoff.
Liftoff
Yes,
of the
there we
United
go.
Launch
Oh my
Alliance
god,
Atlas V
I
rocket
like
with
this.
AFSPC-11
This
for the
is
United
so
States
epic.
Air Force.
Oh. Yes, go, go, go.
Pressure across all 5 SRBs. PU's gone to closed loop control. Now passing 20 seconds into flight. Continue to see good pump speeds and injector pressures on the RD-180.
Ooh, live on board video.
30 seconds in. And vehicle's now passing Mach 1. SRB chamber pressure continues to look good across all 5 SRBs.
Yes, liftoff, yeah.
You are hearing the
Now
voice
passing
of
max
Patrick
Q,
Moore
maximum
providing
dynamic
launch
pressure.
vehicle ascent data.
The clock is stuck at 0.
And pump speeds and injector pressures on the RD-180 continue to look good.
Oh my god.
SRB chamber pressure is also looking good.
Ooh,
Now passing
you
1
can
minute
see
into flight.
watch for the
And the launch
pretty
vehicle is now
supersonic,
11 miles in altitude, 7 miles downrange distance, traveling
the
at
shockwave, yeah.
2,300 miles per hour.
We have a great
1
tracking
minute,
camera.
15 seconds into flight.
About now
And
we should
be
see.
expecting SRB burnout momentarily.
Oh, we already
Chamber
missed
pressure
it.
on the SRB is tailing off.
Wow.
And we have burnout on all 5 SRBs.
Should separate in 20 seconds.
1 minute, 40 seconds into flight. RD-180 pump speeds and injector pressures look good.
There we go.
In,
1
full
set,
thrust mode.
2 set. Yes.
And we have good jettison of all 5 SRBs.
Look at them tumbling away. Wow.
Vehicle's gone to closed loop guidance. Now passing 2 minutes into flight, Mach 5.
You can see the plume extend of the
And
stage
pump speeds and
expand
injector
as
pressures on the RD-180 continue to look good. Vehicle is now 40 miles in altitude, 55 miles downrange distance,
as
traveling
the
at
atmosphere
4,900
gets
miles per hour.
thinner and thinner, and the gas just spreads out a lot more.
And now passing 2 minutes, 30 seconds into flight, approximately 2 minutes remaining in the Atlas booster phase of flight.
So we should come up on payload fairing.
And the RD-180 is now throttling down to maintain a constant 2.5 G acceleration limit. Engine response and vehicle acceleration response looks good. And the RCS pyro valve is unfired. Reaction control system is now pressurizing the flight levels. Now passing 3 minutes into flight.
So they're pressurizing the Centaur second stage for its firing now.
And seeing good response on the RD-180 pump speeds and injector pressures as vehicle throttles down to maintain that acceleration limit.
2.5 Gs, so wow.
And we're standing by for payload fairing jettison momentarily.
And when that happens, they will cut the stream because it's for the Air Force, so they don't want anyone to see it further. I don't know, but we already know where it's going.
And we have
So
good
ooh,
indication
look at
of
that
payload fairing
flapping
jettison.
away.
And we have good indication of
Yes,
CFLR
that
jettison.
was beautiful. Yeah, they take it to a whole new level, indeed.
And vehicle's now throttling back up to full thrust. RD-180 response looks good.
Wow.
And now passing 4 minutes into flight, and the RD-180 is now throttling to maintain a 4.6 G acceleration limit. And the
Now I
Centaur
don't
is
know
in boost phase chill down sequence.
what we're gonna see.
Pump speeds and injector pressures on the RD-180 continue to look good. Vehicle is now 90 miles in altitude, 328 miles downrange distance, traveling at
I guess they have
12,000
some
correction,
problems.
13,000 miles per hour.
I think we're supposed to
And
see
standing by for Pico momentarily.
the animation,
And we have Pico booster engine cutoff, standing by for stage separation.
stage separation.
And we have good indication of stage separation. We have pre-start on the RL-10. And we have ignition on the RL.
This is Atlas Mission Control at T plus 5 minutes. Patrick Moore just confirmed the successful completion of the early phase of today's flight, and all systems continue to operate nominally.
Okay.
In addition to learning more about the Eagle bus, which is on its way to orbit at this very moment, I also had the chance to meet with Major Liz Deneve, Eagle Systems Engineer, to hear about Mycroft, one of the 6 payloads attached to the Eagle bus.
Major Deneve, what's the objective of the Mycroft payload?
Well, the Mycroft will investigate advanced guidance, navigation and control, and flight safety methods at geosynchronous Earth orbit, or GEO. Additionally, the Mycroft experiment will advance key technologies supporting a self-inspection capability and explore new and responsive ways to improve the timeliness of orbit determination for threat warnings at GEO.
Can you tell me a little bit more about self-inspection capability?
Well, self-inspection is just as it sounds. It's inspection of one's own spacecraft. In this case, Mycroft will inspect the Eagle spacecraft. If our spacecraft was experiencing an anomalous behavior, perhaps the output of the power system is less than expected, a timely self-inspection capability would help us to determine the cause. Perhaps the solar arrays didn't fully deploy. The Air Force continues to pursue, adapt, and evolve the unique technologies, innovative techniques, and diverse applications that give the United States its strategic advantage in space. Many of these technologies are restricted by export control laws. The Air Force is protecting United States technologies that may play a role in future operational capability and maintain the strategic advantage in the increasingly congested,
So I don't know what
competitive,
we're
and
going to see
potentially
now,
contested
but
space environment.
Wow. Can you tell me a little bit more about some of Mycroft's unique capabilities?
Yes, the Air Force AFRL Space Vehicles Directorate's mission to develop and transition innovative, high-payoff space technologies supporting the warfighter, while leveraging commercial, civil, and other government space capabilities to ensure America's advantage. Mycroft will advance key technologies supporting a self-inspection capability and explore new and responsive ways to improve the timeliness of orbit determination for threat warnings in GEO.
Tell me a little bit more about some of Mycroft's operations.
Well, Mycroft will conduct safe proximity operations with the AFRL Eagle spacecraft. It will operate within 10 kilometers of the Eagle Esper ring within approved policy limits. AFRL protects technologies, performance, and capabilities so they are viable for transition to the operational systems.
How does the AFRL transfer technology?
AFRL transitions knowledge, products, and vision to our customers. This not only includes hardware and software for space applications, but also the know-how to achieve new space capabilities. Furthermore, AFRL provides concepts that address the potential future space environment. AFRL responds directly to customer technology needs as well as leads discovery of new innovative technologies.
Thanks for coming in and speaking with me today.
Thanks for having me.
I'd like to thank Patrick Moore for his support for today's show. If you'd like to know more about the Atlas V, please visit ulalaunch.com or visit us online at Facebook and Twitter. We'll complete our live coverage with another look at today's liftoff, which occurred at 7:13 p.m.
So they're
Eastern
ending
Time.
the stream right now.
I'm Tyler Strickland, and on behalf of the entire launch team, thank you for joining us, and have a great night.
So because it's an Air Force mission, they won't show the whole launch. So they won't show the engines cutting off and the coasting phase and starting up at over the equator again, and they won't show it because it's a Air Force mission, and the Air Force does not want anyone peeking into their mission. So yeah.
30 seconds in.
And
vehicle's now passing Mach 1.
Leave with that. So, thanks again for watching, and see you in the next one.